Okay, so today I will be discussing standard deviation. Standard deviation basically shows how much group of data varies from its mean. So a lower result would indicate little variation from the mean, while a larger result would indicate more variation. So to calculate standard deviation, we use this equation. It looks scary, right? But it is actually quite simple and, not that hard once you know what everything means and how to handle it. So, this is, of course, just the standard deviation that we are trying to calculate. N is the number of trials in our group of data. Then x of I is the individual measure. So this would just be like one measure that you took from a single trial, the measure that you got in a single trial. And then x bar is the average measure from all of the trials. And then the sigma indicates that you're going to take everything that you get from this part of the equation and add it up, which will make more sense as we go on. So, to show it further, I will just do an example problem. So let's say we have 5 points of data for this. 3.03, 3.05, 3.08, 2, and 4.2. Okay, so the first step of solving this is to average these all out, because you need to know that in order to do part of that equation. So averaging them all, you just add them together and then divide them by 5. Because that's the number of trials we have. And for that I got 3.072, and we should actually put units for these, so I'll just say meters. Okay, so now we just take this as well as the individual points of data, the average and the points of data, and put them into this last part of the equation. So we'll take 3.03 minus 3.072 and square it. And we'll do that for each of these. That should come out to 0.00, I'll round it to 18. Then, you just do the same thing for each of these. Keep the proper amount of significant figures, of course. Oops. Got a bit ahead of myself there. Oh, right, that's the last one, sorry. That's a 6. Okay, so, oops, that paper got out of the shot a bit. So once we have all of these pieces of the equation, or rather of this last part, we do as the sigma says and add them all together. So, it would have been useful if along your way, if you have a graphing calculator like this, if you store your answers. So, like for example, 3.03 minus 3.072 squared, you can press the STO, so focusing, this store button, and then alpha and whatever letter you would want to save it as. And then at the end of the equation, you can just add them all together. But if you have a lot of them, it can be useful to write what they are on the paper, so I should have done that. I just used the first 5 letters of the alphabet, so okay, so now, sorry about that. Now that we have all of these, we add them all together, find their average, so divide the answer that you get from this by 5. I got So divide that by 5. Oops. And then find its square root. So, 1 second. And I got a standard deviation of 0.6357 meters. Okay, so that's all there is to it.